Good morning. Today we are working on 8.4, adding and subtracting rational expressions. This will be part 1 of 2. This is Algebra 2 TEKS 2A.7F, which is determine the sum, difference, product, and quotient of rational expressions. So we're going to start with the first question. Now we're going to start off very basic where we already have the same denominator. In order to add or subtract the rational expressions, the denominator must be the same. Once the denominator is the same, we can actually write this over 3x, and we have 14 minus 7 on top. So 14 minus 7 is 7 over 3x. One thing we need to discuss, though, is that x is all real numbers. We can plug in any number there, and it'll make this expression. We can do this expression, but except for where your denominator equals to 0. Because remember that you cannot have a division by 0. So we can either start, I either do this at the beginning or at the end. Because these were common denominators, I just waited for the end. So we also need to know that 3x, where does 3x equal 0? Well, if I divide by 3 on both sides, x cannot be equal to 0. So I'm going to leave all of that as part of my answer. Those are called domain restrictions because it affects your x value. So on number 2, my denominators are the same. And if the denominators are the same, then I can rewrite this as 1 fraction. On my numerator, because it's a plus sign, I can actually bring down everything just the way it is. Now I'm going to combine like terms. I have negative 2x plus 3x, that gives me 1x. Then I have 5 plus 4, that gives me a positive 9, all divided by x plus 1. If I can't reduce that anymore, then that is my answer. But again, we're going to talk about that domain restriction. Set your denominator equal to 0. Subtract 1 from both sides. Add x equals negative 1. That's a domain restriction. So x cannot equal to negative 1. So if I were to take my original expressions and plug a negative 1 in there, I wouldn't be able to do it because it would be undefined. One more question with the denominators already being the same. So when my denominators are the same, I can write 1 fraction. And I'm going to go ahead and put my numerator together. Now with this numerator, I'm going to go ahead and actually write it in the right order. What I mean by that is I'm going to start with the x squared, but I'm going to actually put this one next just because we typically go x squared, x, and then the number. So x squared, x, and then the number. Well, we also want to check. This goes back to when we simplified rational expressions. Is my numerator, is it factorable? Are there two numbers that multiply to negative 4 but add to 3? Now I started with the x's already because my a value is 1. Okay, so an a is 1 and I'm factoring, it becomes an x and an x. So again, we're looking at things that multiply to negative 4. But if I add them together, they give me negative 3. So I have 1 and 4, 2 and 2. One of them has to be a negative because they multiply to negative 4. So don't forget that the second term is going to tell you the bigger number is a negative. So 1 minus 4 actually gives you the correct values. Okay. If they are the same on the numerator and denominator, if the linear factor is the same, we can actually, these do divide to 1. So my answer is actually just x minus 4. Now here's the dilemma with doing domain restriction at the end. I don't have a domain there, so you would think there's no restriction, but I do have a restriction because this denominator cannot equal 0. So I still have to do domain restriction with this value. So x plus 1 equals 0. Subtract 1 from both sides. When x equals to negative 1, there is a domain restriction. Okay. Now we are going to get in, what if my denominators are not the same? How can I find the least common multiple of my denominators? Okay. So we're going to start with, what if these were my denominators? I want to find the least common multiple of these. So my least common multiple is, what can these multiply? What can these turn into if I multiply that they would be exactly the same terms? Well, what are the different things I have on the bottom? They both have a 3. Okay. They both have a 3. Then I have this x. And then I have an x minus 2. That would be my least common multiple. So I'm going to want my denominator, if those are my denominators, to be a 3x, x minus 2. Okay. This question, what's my least common multiple? Well, first I'm going to factor. X squared minus 25 is a difference of squares. So this first term factors to x plus 5, x minus 5. So what are all my different things that I have? I have an x plus 5. And this is x minus 5. I don't need to write it one time. So my least common multiple would be x plus 5, x minus 5. Okay. Again, I need to factor. A is 1, so when A is 1, I'm looking for factors of negative 40 that add to positive 3. Well, what are all of my factors of negative 40? I have 1 and 40, 2 and 20, 3 does not go into it, 4 and 10, 5 and 8. One of those numbers has to be a negative because it has to multiply to negative 40. So where can I put a negative that if I combine the two terms would give me a positive 3? Negative 5 plus 8 does equal to 3. So I have x minus 5 and I have x plus 8. So what are all of my different terms? Well, I have an x plus 5, I have an x plus 8, and I have an x minus 8. So my least common multiple would be all three of them next to each other. Now that won't really make a lot of sense until we actually start adding and subtracting the rational expressions, but I wanted us to at least see how do we find the least common multiple. So this is the purpose of us finding the least common multiple. So we look at our denominators. Our denominators are 2 and 3. So what number can 2 and 3 both be multiplied to turn into? What's the first number they both go into? My least common multiple is 6. So I need to make my denominator a 6. Well, how can I make the first one a 6? Well, I multiply it by 3.